Hey everybody, how y'all doing? All right, so we want to give a few moments for people to log in, and as we wait for your classmates to log in, I ask that you take a look at this chart and complete your warm up for me, please. Hopefully, everybody had a great weekend. While we wait, what are some things you all did for your mothers or your aunties or your grandmothers for Mother's Day? Type it in the comments section. Kelvin,
Yeah,
how you doing?
good.
Good. You ready for class now?
hmm
All right, so get on up
I'm up.
and let's get focused.
I'm focused. You see, I'm in the line. Oh, bro, why everybody joining? They not even hood niggas, bro. They
What
need
you
to get
say?
on somewhere, bro.
What you
Huh?
say, Kevin?
I say it's hood people joining the live because of me.
Oh, really?
Yes, they need
All
to
right,
get
Kelvin.
on, bro. Can y'all move?
Kelvin, if you're not participating or acting appropriately, I'm taking you off the live.
All right,
Got it?
my bad. All right,
All
all
right.
right,
Now,
all right.
can you see the warm up question? Can you read it, please?
Yeah, it
Okay.
says the energy of a what that say?
Pendulum. Pendulum.
Pendulum is recorded at a different position in the table below. Use the data in the table to determine the amount of kin kinesthetic
Kinetic.
kinetic energy to the what's that should say? I mean, my bad,
Watch your mouth.
my bad.
Pendulum.
Pendulum had at position 2.
All right. So, in order for us to figure this out, what do we have to do, ladies and gentlemen?
But stop what you doing, bro. Leave it alone.
All right. So, we have how many positions, Kelvin?
3.
We have three positions. They gave
Yeah.
us the joules or the energy for the potential as well as the kinetic. However, for position two, we are missing the kinetic energy. How do we find the missing number?
Are you asking me a question?
I'm asking you a question. Yes. How do we find that missing number? What do we have to do?
Well, first we have to. Can you go back to the joint to the little reading thing?
Okay.
hmm Have to use the table. We have to use the data and the table to determine the amount of kinetic the predator has used to enter position 2.
All right, but what are we going to do exactly? We already established that, but we have a missing number here. What can we do to figure out what that number is? I need y'all to type that in the box for us, please. So think about this. Our total energy is how much for each of them?
100.
100. Okay.
Mm-hmm.
For position number 1, the potential energy was at 72.26, and the kinetic was 27.74, and their total energy was what?
100.
100. So what does this tell you about all 3 positions? Their total energy should be equal to what?
50 to 100.
Okay, so what are we going to do?
Subtract.
Okay, so I need an answer, please.
Okay, 50 subtracted by. Hold on, wait. I gotta get some paper. I can't. I need. Hold on, wait. I
It's
got
not
it.
just on you. It's not just on you. I need
Wait, I got it.
everybody.
I got it. 63.45 minus 50. Hold on. What? So wait. So can I use the zeros as a placeholder?
Okay.
All right. So I'm gonna put the zeros behind the 50. Oh my God, I ain't put zero behind the 50. 0. That's 5. That's 4. That's 3.
So young
That's
boy,
1. That's 13.
you
Point
subtract. So what?
13. Huh?
Go ahead.
That's 13.45.
Are you sure? What's your top number, son? What's your top number?
63.
You
No,
sure?
no, 72.20.
I need
You
you.
talking about in the second column?
What's the total energy?
Oh, 100.
100. So what are we gonna do
Yeah.
with this 63.45?
We're going to subtract it by 50.
What you mean by 50?
By 50, I can't see what it say because the little live thing in the way.
No, all you need to focus on is these two numbers, the 100 and the 63.45.
Oh, you're going to subtract it by 100. No, 50.
Why do you keep getting 50? I'm not understanding.
Could you say 50 is half of 100?
We know 50 is half of 100, but that's not what you're supposed to do. So let's take a look at our comments. We say, someone says 100 subtract 63. Exactly. So we take
I just said
100.
100 and you got quiet. So I thought I was wrong.
No. Always be confident in your answers, okay? You take 100 and minus 63.45. What's that final answer?
Wait. 100. 100. Yeah. All right, man.
Help them out, y'all. What y'all have?
I'll be back.
Thank you, Joel. Good job. Thank you so much. All right, so the answer is 36.55. Okay. Let's move on. I want to talk about this quote real quick. I want to give you all a quote of the day every time that I teach you all. So this one says, tell me and I forget, teach me and I remember, involve me and I learn. Okay. Milani, if you are here, you can call in. You can go live. Milani, if you are here, you can call in. Okay. So what this quote basically means is we want, as teachers, our job is to always involve you so you can actually learn from the experience. It's more than just telling you about a problem or a lab activity or situation. We want to make sure that we do all of these things, but most importantly, we want to involve you. And that's how you all are able to learn more. Okay? For our objective for today, we have 2 objectives for today. The first one is by the end of the lesson, students will be able to analyze the relationship between potential and kinetic energy. Again, we're still working on potential and kinetic energy. We're going to write a scientific explanation that explains when the roller coaster has the most kinetic energy using claim, evidence, and reasoning. Okay, so today we're still talking about the relationship between kinetic and potential, and we still want to emphasize how we write claim, evidence, and reasoning. That is the goal. Okay. Hey, Milani.
Hey, Miss Tate.
How are you?
I'm good.
All right.
So what
Let
page
me
are we
ask
on
you this.
again? Cause I did not see this, and we
You
still
don't
on
see
we.
what?
I don't see the paper that we going to be on. We going to be going on today.
Really? Okay, well, we're not on that part you right now. So just give me your undivided attention, okay? I'll tell you when we're there. Okay?
Okay. All right.
Let me get a thumbs up if you all actually went to this simulation and completed the skate park activity. We are actually using week 6 packet. We're actually using week
Oh.
6 packet. Okay? Let me get a thumbs up if
Okay.
you actually went to the energy skate park simulation activity that I gave you all last week. Let me get a thumbs up. Milani, did you go?
No.
You didn't? All right, so last
Mm-mm.
week your job was to visit this website, and there were instructions on Canvas for you to complete it as well as a worksheet. Your job was to visit
Oh.
all these and actually create, play around with potential and kinetic energy. Can y'all see this? Trying to get it together for you guys. Okay. Your job was to play around with, you take a look here, we have speed and mass, okay? And that is a direct correlation with potential and kinetic energy. So, Milani, if I was to put more mass on my skater, how does that, what's the relationship with that with speed? Meaning, if I was to make my skater a little heavier, what should happen with the speed? Would it go up
Like, what
or
would
would
be the
it go down?
relation? What do you mean?
When it comes to kinetic energy, think
Uh
about what we
huh.
talked about last week.
Right.
If you increase the mass, what else should increase?
The kinetic energy.
Potential energy at the top of the roller coaster. Kinetic energy is at the bottom of the roller coaster. Okay. All right. All right. As I'm going through the comments, your job was to visit this website. You see how we have these little red, you see this, Milani? Playing around with this?
The little 3 red dot things.
Yeah, it's the 3 little red dot things. Your job was to create a skateboard part for your skater. Now, what should I do? What is going to make my skater go faster? What should I create? What should I add to this? Should it stick? Should it remain flat?
Like a lower ramp.
Okay,
Like a
make ramp.
lower yeah, like a lower. Yeah, but you should make it higher. You should make it higher
So why should I make it higher, Milani and friends? Why
because
should I
it'll
make it
have
higher?
if it'll have more potential energy at the front. I mean, it'll have more potential energy and it'll move faster.
Oh, okay. So you're saying since it's higher up, it's going to have more potential energy and it's going to move faster. So answer me this. So will I have higher potential energy here or here at the bottom?
Say,
Will I have higher potential energy here
uh-huh.
or here, which is at the bottom?
At the top.
I can't hear you, Milana.
You'll have more potential energy at the top.
At the top, okay.
Yep,
And
at the
that's
top.
because of, is that because of the position or how it,
Yeah,
or
it's
the
because of how
location?
high you have it. It's because of how high, like the position of the way you made the skate, him to
Thank
skate.
you. Thank you. Okay. All right. So your job was to go and visit this skateboard park and play around with it. And as your skateboard is going, you can take a look at the speed, the mass, the pie chart, and all of those. so you can see what actually happens as you increase or decrease. I'm sorry, y'all. I'm trying to get this together. As you increase or as you change the energies, okay? The key takeaway from here is you all should be able to understand the energy is being transferred from potential energy all the way through kinetic and keeps going, okay? So as it goes down here, he's experienced kinetic, and of course he's going up here, he's experienced potential, and vice versa, okay? Excuse me. Excuse me.
Mm-hmm.
So that was the goal for you all's lesson, your class last week. I'm sorry for talking. That was one of the goals. So if you have not gotten that completed, you need to get to that place immediately. Well, once we finish our lesson for today, so you can get a feel for how this thing works. Okay. Do we have any questions about this?
So you look sick.
My allergies are bothering me. Okay. All right.
Oh.
So
Okay.
I'm trying to get this together. It's not acting right. Okay. So. All right, so we went over this already. Oh no, wait a minute. All right, so we went over this, our agenda. We went over our warm-up and our objective. We reviewed
Mm-hmm.
potential and kinetic already. We discussed the energy park basics, which you all need to work on. I actually put a post on my Instagram page, trying to get a feel for how it went for you guys, and no one at this point, no one has actually answered the question that I placed on Instagram. So I asked that you do it and
It's
answer the question.
a question on there?
So it's a question in regards to what actually happened, or how did you feel? What were your challenges or struggles while you were completing the Energy Park Basics? So it is. So go to my page. There's a post there. Okay. If you take a look, we are
Okay.
going to be working on week 6 packet. Make sure you all have that
Yeah,
out and
let me
ready.
see, because I had to print it out from my house. So let me see. Let me.
All right. So before you go to your packet, Melody and friends, I need everybody to pay attention and take a look at this sandstone boulder. Do y'all see that? Give me a thumbs up if you can see this boulder. Give me a thumbs up if you can see this boulder. Okay. All right. So, is this boulder displaying kinetic or potential energy? And please share with me, how do you know? Again, is this boulder displaying kinetic or potential energy? And explain, how do you know? Type that in the box for me, please. Type it in the comments. Jules said potential energy because it's at the top. Okay. Anybody else? Jewel, please explain, is at the top of what? Top of a hill, top of a slope, top of the refrigerator? Like, where is it specifically? It has potential energy at the top of the hill. When it get to the bottom, it have less potential energy and have more. Very good, Taimani. Very good. Kinetic because it's about to roll down the hill and it's just like the roller coaster. Okay, very good, Grace. Very good. All right, so you guys are absolutely correct. Okay. Take a look at the last bullet. It says, what can change? What can change the amount of potential energy in this object? So right now, the object is at the top of the actual boulder. I'm sorry, at the top of the mountain or the hill. What can change the amount of potential energy? Because right now it has a lot of potential energy. Okay. What can change that? I'm ready for you all to comment below. So you all have already stated that right now it has potential energy, it's sitting up high. And as it goes, I believe it was Taimani, she said as it gets to the bottom, it turns into kinetic. Okay. What can change that? You all already said it. If it falls, thank you. The rock maybe. If you roll it down the hill, it would increase speed. Absolutely, Jewel. If it falls, very good, McMillan. Okay. Very good. If the boulder was small or if the slope was, it says if the boulder was small or if the slope or hill was changed. Very good. All those are absolute correct answers. Very good. Thank you. Okay. All right. So basically we answered this question. It says, what do you notice about the position of the boulder? Explain its relationship to potential energy. We already said that it rests on a steep slope. Okay. And you all basically said if it moves, that the potential energy will change and it will fall at any moment. Okay. Basically said that. My next question was, how can the potential energy in this, how can the potential energy in this boulder become kinetic energy? And we basically discussed and talked about that already. So we're about to watch a short video. I want you all to make a prediction about what will happen to the boulder as far as position, speed, etc. The cool thing is the questions that I've been asking you, you all have basically answered them already. But I want you all to watch this short video, make your predictions at the bottom on the comments, make your predictions, and tell us what you think will happen to the boulder as far as speed, position, etc. Okay? Yes, it is tilted. Melania, I'll let you join back once we get back to the packet. Okay, I'll let you join in once we get back to the packet. All right. All right, so I'm about to show this video real quick. All right. If you're on top of a hill and you see a rock, it is human instinct to want to push that rock down the hill, or at least it is for me. And so here's our list of the top 5 rock versus hill videos. Estamos indo agora para a quarta tentativa. Só a pegadinha. 3, veio o demônio. Olha. All right. So, what are some things that you noticed in the film? Did it match up with your predictions? Type it in the comment section, please. Did the rocks falling, their positions or whatever, did it match up with what your predictions were? Type in the box, yes or no. Joel said yes, it did. Taimani, did it match up with your position, with your prediction, Taimani? So my question was, did the video match up with your prediction of the rocks? So the key thing in this video was what? Please type that in the box. We know about rocks, but as far as position and speed, what are some key takeaways from this video when it comes to potential and kinetic energy? So type in some takeaways from the video, please. It had more potential energy at the top than it did at the, okay, yeah. It started at potential energy at the top of the hill, then rolled down, which caused it to have kinetic energy, correct? To get the rock down the hill. It's because when the part of the mountain was falling, it was getting some kinetic, very good. It was gaining some kinetic energy. Okay. Finish that statement, Grace. I like that statement. We should change getting. We should change the word getting. Should be, let's change that to gaining. Okay, because as it's going closer and closer to the ground, it's gaining more and more kinetic energy. Okay. Very good, love. Very good. Now, do we have any questions about that? Thank you. When the rock was falling, the kinetic energy made a decent smash, then a major one. Okay. What's the difference between a decent smash and a major one? This kind. So what I want you all to understand is the rock at once it was at the beginning of the at the very top of here, it was at potential. It had a high potential energy. The percentage was very high, but as it got closer and closer to the bottom, that potential energy transferred to kinetic energy, and it should have been moving faster or slower. Type it in the box for me. By the time it got to the ground, or excuse me, by the time it made its way to the ground, was it moving faster or moving slower? Type that in the box for me, please. Thank you. Gaining more kinetic energy. Very good. It moved faster. Very good. So we can move on, right? So please take out your, Grace said, when it's, yeah, so when it's gaining more kinetic energy, I think it was so much that when it hit the ground, it turned into potential energy. Okay, because when it hit the ground, it eventually stopped. Keep in mind, potential energy is stored energy. It's not necessarily moving. Thank you, Grace. Thank you. Okay. Let's turn to your packets. We should be on this page here in your packet. Potential energy card sort. Let me see something here. So we have already answered those two questions up there. But right now, they actually wanted you all to take a look at this card sort right here. Everybody have this? So let's take a look at your card sort. And they want you all to organize these picture cards into two groups. Okay, so one group you had to identify the cards that show energy in motion. And the other group you had to identify the cards that shows energy waiting to happen. So the energy in motion deals with which type of energy? Type it in the box. The energy in motion deals with which type of energy? Type it in the comment section. If something is in motion, what type of energy is that? Milani, we are on week 6. And at the top of this page, it should say potential energy card set. So in actuality, they want you to cut these cards out, determine which one is considered moving or in motion, and determine which one is not in motion. Of course, the one that's in motion deals with which type of energy. I'm still waiting for that answer. Thank you, kinetic. Thank you, thank you, thank you, thank you. Okay, let's take a look at when it comes to identifying group cards that show the energy waiting to happen. What type of energy is that? Type it in the box, please. So we already said it was kinetic. If energy is waiting to happen, what is that energy considered to be? Still waiting for y'all answers. Potential. Thank you. Thank you so much. Thank you so much. So let's take a look at this apple. Is the apple kinetic or potential? Is the apple kinetic or potential? Okay, the apple is actually potential. Okay, it does not give you energy. In actuality, when we eat the apple or the plum or the cherries or whatever food that we eat, that energy is potential until we eat it and our body digests it. Sorry, y'all. That's a delivery. I'm sorry. Once our body digests that food, start to digest it, break it down, that potential energy is transferred into chemical energy. Okay? All right. So let's take a look at this horse. Is this horse displaying kinetic energy or potential energy? Kinetic energy or potential energy? Look at the position of the horse. Young boy Reed, why is it kinetic? How do you know it's kinetic? Tariq. What helps you identify that it is kinetic? What do you see in the picture? It's moving. Thank you. All you gotta do is take a look at the legs, and it is actually moving. Okay. Take a look up here. The roller coaster or the skateboard. No, that's a roller coaster. Okay. Take a look there. What type of energy is that? Kinetic or potential? Skateboard. Kinetic or potential? Very good. It's in motion. It's in motion. That was for the past one. We on the skateboard now. Right now, I think it's potential. That's what Tyreek said. So, absolutely. It is just sitting at the top waiting to actually go. So this one is potential. Okay. So that's what you would have to do when it comes to all of these cards. You have to put them in two groups and determine and identify if it is moving. I'm sorry, if it's in motion or if it's energy that's waiting to happen. Okay. I want to do this next one here when it comes to this everlast battery. Everlasting battery. Is that kinetic energy or is that potential energy? Type that in the box for me, please. Come on, y'all. Let's pay attention. Is this battery kinetic or potential energy? Is it being used or waiting to be used? Is it in motion or waiting to be used? Which one is it? Potential. Thank you. We use batteries for lots of things. Case in point, I know a lot of you all have been using this. Can y'all see what this is? Can y'all see what this is? Type in the comment section if you know what this is. It's a remote. Very good. Now, in order for the remote to work properly, what do we need? In order for it to work properly, what do we need? What do we need? We actually need batteries. Thank you, Jewel and friends. We need Can you see the batteries in here? Trying to get y'all to see the batteries. All right, we need batteries. So at this point right now, we're not using the actual, we're not using the batteries right now, only when we are changing the channel. So at this point, it's not in motion, it's not being used, that is kinetic. I'm sorry, that is potential. Okay? Are there any questions about what you're supposed to be doing on this particular sheet? Give me a thumbs up if you understand everything. Young boy Reek understands. Come on, y'all, I need a thumbs up if you understand. Thank you, Jewel. Thank you, Tyreek. All right. So that's what the goal was for this particular sheet. You're supposed to cut these out and make your two groups so you can identify what's what. All right. So moving on. We have about 5 minutes left in class. This is not enough time for us, but this is what I want you all to do. Tonight, way before Wednesday, I want you to complete this activity, okay? Your job is to complete the investigation on potential and kinetic energy and claim evidence and reasoning. If you don't have the materials, just predict what you think the data may be, okay? Is there anybody who wants to join in to read this part? Or you could just continue reading from your you can just continue reading from your packet. All right. So, potential predictions. The force of gravity can cause objects within the system to interact. The mass of the objects and the distance between them are the variables that control how gravitational energy is stored in the system. Okay? Stored in the system. Why do they say that the potential energy is stored in the system? Why does it say potential energy is stored in the system? Because it needed of motion? Okay, because it's without motion. It's without motion. You said like humans. Explain to me what you mean by like humans. Explain to me what you mean this time. Explain to me what you mean. How is it like humans? We basically have a system that controls our moves, okay? But how do we how does that system make us move? How does it control us? What do we need in order for it to control our moves? So it's like potential energy, okay. Where do we get our initial energy from as humans? Where do we get our potential energy, our initial energy from as humans? So when it comes to blood and DNA, is the DNA actually moving in your body? How does the blood move throughout our body? What do we need to keep energy going within our body? What do we need to do? What about vines? Well, I don't understand. Veins? Thank you. We get our initial energy from the food that we eat. In order for us to walk up and down the stairs or exercise or play around or play a sport or something, we need to be sure that we feed our bodies and get energy from the food that we eat. Okay? And after we eat our food, that sometimes that food sits on your stomach and it becomes stored potential energy. So let's say if I ate lunch today, I had me a nice little salad, some breadsticks, or some water. I get my energy from that. However, if I was to go work out tonight, what's going to happen to that energy I got from my food? What's going to happen to the energy I got from the food? Will it continue to be potential energy? Or will it turn into something else? That's the question I'm going to leave you all with today. Okay? Everyone work out now. Weird. Okay. The food breaks down and makes energy for our body. Absolutely. Thank you. Thank you. The food breaks down and makes energy for our body. Some of it is stored and some of it is used. But sometimes, if we have too much stored energy, sometimes some people have a little extra weight on them because they have a lot of stored energy. Okay? All right, so what I want you all to do for tonight, if there's no more questions, what I want you all to do for tonight is you're going to read through this particular sheet, and we're going to prep ourselves and be ready to create a claim, evidence, and reasoning based on this situation. Okay? All right. They are asking you guys to use a meter stick and a bouncy ball. Now, you may not have a meter stick in your home, okay, which is fine. You can sort of measure. Let me take this off. You can sort of measure, because I don't have a meter stick in my home either. But what I did was, you see this here? I sort of taped this little measuring tape to my wall. Okay. I taped it to my wall. And they want you to use that as well as a bouncy ball. So I have a bouncy ball right here. See that? Okay. So if you're able to do this lab using the meter stick or measuring tape and a bouncy ball, please do so. Okay. But if you don't have the material, predict what your data may be. Okay. So that's what we're going to talk about come Wednesday. Make sure you all are prepared. Also, go on Canvas and complete your assignments, especially the energy skate park activity. If you have any questions or concerns, you all know how to reach me. And I will talk to you guys later. Okay?